welcome to our deep dive into a moment that's truly pushing the boundaries of space exploration.
Yeah.
It's December 2024, and humanity has just achieved something remarkable.
Wow.
NASA's Parker Solar Probe has survived the closest ever approach to the sun.
Oh, wow.
Coming within a scorching 3.8 million miles of the solar surface.
That's incredible.
And this isn't just about breaking records.
Right.
This mission is revolutionizing our understanding of the star.
Yeah.
That powers our entire existence.
It's truly a historic moment in our quest to understand the sun.
So let's unpack this a bit.
Okay.
The Parker Solar Probe launched back in 2018 with the incredibly ambitious goal of touching the sun.
Yeah.
They actually used the gravity of Venus, like a cosmic slingshot,
Good.
to get the probe closer and closer to the sun over several years.
Right.
And then just last month, in November 2024,
Yeah.
it reached its ideal orbit after the final Venus flyby.
Yes. And what's fascinating here is that this orbit, shaped like an oval, brings the probe close enough to study the sun's mysteries without being completely incinerated by the intense heat and radiation.
Right.
It makes these close approaches every 3 months, gathering valuable data each time.
Okay, so it's kind of like playing a very high-stakes game of chicken with the sun.
Yeah.
Speaking of which, just how close is 3.8 million miles in the grand scheme of space?
Well, imagine this.
Yeah.
If the distance between the sun and Earth were a football field,
Okay.
the Parker Solar Probe would be just 4 yards away from the end zone.
Wow.
It really gives you a sense of just how close this probe is getting to our star.
That's an incredible image.
Isn't it?
And we can't forget the speed.
No.
Parker was flying through the sun's atmosphere at an astounding 430,000 miles per hour during this close approach, making it the fastest human-made object ever.
It's unbelievable.
But I have to ask,
Sure.
how does anything survive in the million-degree Fahrenheit temperatures of the sun's corona?
That's where the remarkable engineering comes in.
Okay.
The probe is shielded by a cutting-edge heat shield made of a special type of carbon foam.
Oh, wow.
It's not just any foam, though.
Right.
It's actually a sandwich of 2 carbon plates with a lightweight carbon foam core.
I see.
This design allows it to reflect most of the sun's heat away while remaining incredibly strong and lightweight.
That's like a cosmic oven mitt,
Exactly.
keeping the probe safe while it's in this extreme environment.
Yes.
But the real question is, what's it finding out there?
Right.
I know Parker has already sent back some surprising data.
You're absolutely right.
Okay.
One of the biggest mysteries the mission aims to solve
Yeah.
is how the sun's corona gets so incredibly hot.
Okay.
The sun's surface is around 10,000 degrees Fahrenheit, but the corona, which is further out, can reach millions of degrees.
It seems counterintuitive, right?
It does, doesn't it?
Yeah, it's like the air around a campfire being hotter than the flames themselves.
Yeah.
How is that even possible?
Well, scientists have a couple of theories.
Okay.
One leading idea is that tiny explosions, called nanoflares, are constantly happening on the sun's surface, releasing energy that heats the corona.
Oh, I see.
Another possibility is that magnetic waves transfer energy outwards from the sun's interior,
Okay.
heating up the corona in the process.
So they're not sure.
Not exactly.
Okay.
Parker is gathering data that will help scientists determine which of these theories,
Yeah.
or perhaps a combination of both,
Okay.
is responsible for this intense heat.
So Parker is basically acting like a detective,
Exactly.
collecting clues to help us solve this cosmic puzzle.
Yes,
That's pretty cool.
it is fascinating.
And what about those other mysteries we were talking about?
Like what?
Like the solar wind.
Right. Another key focus is the solar wind.
Yeah,
That constant stream of charged particles flowing out from the sun.
Right.
We experience it here on Earth in the form of auroras,
Yeah.
but it also has a huge impact on the entire solar system.
I remember reading that Parker actually traced these strange zigzag patterns in the solar wind called switchbacks back to their origin on the sun's surface.
You're thinking about the findings from the 2021 pass.
Yeah.
It was a huge breakthrough.
Wow.
Scientists have been puzzled by these switchbacks for decades.
Really?
And Parker provided the first real clue as to how they form.
Interesting.
It seems they might originate from magnetic funnels near the sun's surface,
Okay.
but we need more data to confirm that.
And speaking of data,
Yeah.
I understand Parker made some interesting observations about Venus during its flybys, too.
You're right.
It wasn't just focused on the sun, was it?
You're right, it wasn't.
Okay.
As Parker was using Venus's gravity to slingshot closer to the sun, it actually gathered some fascinating data about Venus itself.
Interesting.
For instance, did you know Venus has a faint dust ring around it?
No, I didn't.
Parker was the first to capture a full image of it.
Wow. So this little probe is quite the multitasker, gathering intel on multiple celestial bodies as it zips around.
It is quite impressive.
What else did it learn about Venus?
Well, it documented Venus's natural radio emissions coming from its atmosphere.
Oh, wow.
Which can tell us about its composition and temperature.
Okay, so this mission is truly revealing new information about our solar system on multiple fronts.
Absolutely.
But let's get back to the main event.
Okay.
What was so special about this latest close approach in December?
This recent pass was particularly significant because it brought the probe closer to the sun than ever before.
Okay.
And that means it entered a region of the corona that has never been explored before.
Wow.
The data from this close approach is still being beamed back to Earth.
So we don't have it yet?
All of it.
Okay.
And scientists are eagerly awaiting its arrival.
It must be like opening a time capsule from the heart of our star.
It really is.
I'm on the edge of my seat.
I understand the feeling.
What are scientists hoping to learn from this new data?
Well, remember, those wrinkles and valleys Parker found in the corona's outer boundary back in 2021.
Yes. That was a big surprise, wasn't it?
It was.
They weren't expecting that at all.
Exactly. Scientists are hoping this new data will shed light on what causes those wrinkles and how they influence the behavior of the corona.
I see.
They're also hoping to learn more about the origin and acceleration of solar energetic particles.
Okay.
Which are basically like tiny bullets of energy blasted out by the sun.
Wow.
These particles can be dangerous to astronauts and satellites.
Right.
So understanding them is crucial.
It sounds like we're on the verge of some major breakthroughs in our understanding of the sun.
I think so.
This latest data could be a real game changer.
I agree. It really has the potential to rewrite the textbooks on solar science. Joe Westlake, the director of NASA's Heliophysics Division, said it best. The data that will come down from the spacecraft will be fresh information about a place that we as humanity have never been.
That sends chills down my spine.
Yeah.
It's like we're exploring an entirely new world right here in our own solar system.
Yeah.
And Parker is leading the way. But it's not just about pushing the boundaries of exploration, it's about the knowledge we gain.
Right.
What are the broader implications of understanding the sun better?
That's a great question. By studying the sun up close, we're not only gaining insights into our own star, but we're also learning about the fundamental processes that govern stars throughout the universe.
Yeah.
It's like having a front row seat to the most incredible physics experiment imaginable.
So it's not just about our solar system, it's about understanding the cosmos as a whole.
Exactly.
That's mind-boggling.
It is pretty amazing.
Yeah.
And the more we learn about stars, the better we can understand the conditions needed for life to exist elsewhere. Think about it.
Yeah.
The sun provides the energy that makes life on Earth possible.
Right.
So by studying the sun, we're essentially learning about the fundamental ingredients of life itself.
That's a profound thought. So Parker's mission is not just about understanding a star. It's about understanding the potential for life beyond Earth.
You got it. And speaking of life beyond Earth, Parker's observations of coronal mass ejections, or CMEs, have some interesting implications for the search for habitable planets.
Oh, right. I remember reading about those findings. CMEs are those massive explosions on the sun that can send huge bursts of energy and particles hurtling through space, right?
Precisely. And what Parker observes was that these CMEs act like giant vacuum cleaners as they sweep through space, sucking up dust along the way.
Oh, I never would have imagined that. So these CMEs are basically clearing out a path through space. What does that mean for other planets?
Well, it could have both positive and negative implications. On the one hand, it means that planets in the path of a CME could be bombarded with harmful radiation and particles potentially making them less hospitable to life.
That doesn't sound good.
No, it doesn't.
Yeah.
But on the other hand, this cleaning action could also play a role in the formation of planetary systems by helping to clear out debris and allowing planets to form more easily.
So it's a double-edged sword.
Yeah.
It's fascinating how even these seemingly destructive events can have a role to play in the grand scheme of things.
Absolutely.
Oh.
And it just goes to show how much we still have to learn about the complex dynamics of our solar system and the universe beyond.
It's a humbling thought, isn't it?
It really is. And Parker's mission is a testament to human curiosity and our drive to explore the unknown.
And this journey of discovery isn't over yet, is it? I understand Parker has more close encounters with the sun planned for the future.
You're right, Parker is scheduled for 2 more close solar passes in 2025, one in March and another in June. With each pass, the probe will venture deeper into corona, gathering even more valuable data and refining our understanding of this enigmatic star.
It makes you wonder what other surprises await us. What new mysteries will Parker unravel in the coming years? It's exciting to think about. And speaking of unraveling mysteries, didn't Parker make some unexpected discoveries about the sun's magnetic field?
You bet. One of the most intriguing findings has been the discovery of these rogue magnetic waves called Alphen waves that seem to be whipping through the corona, almost like a cosmic whip.
A cosmic whip? That's a wild image. What's the significance of these rogue waves?
Well, scientists believe they could be playing a key role in heating the corona.
Okay.
They're also thought to be involved in the acceleration of solar wind particles, those charged particles that stream out from the sun.
So these rogue waves are potentially connected to those two big mysteries we talked about earlier, the corona's extreme heat and the solar wind.
Exactly. And that's what makes Parker's discovery so exciting. They're not just isolated findings. They're connecting the dots between different phenomena and helping us to see the bigger picture.
It's like putting together a cosmic jigsaw puzzle. Each new piece of information helps us to see the whole picture more clearly.
That's a great analogy. And with each close approach, Parker is adding more pieces to that puzzle, giving us a deeper and more nuanced understanding of our sun.
It's incredible to think that a little probe launched from Earth is helping us unlock the secrets of a star millions of miles away. It really speaks to the power of human ingenuity and the boundless potential of scientific exploration.
I couldn't agree more. And it begs the question, what other wonders are out there just beyond our current reach waiting to be discovered? What other mysteries of the universe are waiting to be unraveled?
That's a thought that truly sparks the imagination. It makes you realize that we're living in an age of incredible discovery and we're just getting started. But for now, let's shift our focus back to Earth for a moment.
Sounds good. What did you have in mind?
Well, beyond those stunning auroras, the sun's influence is literally everywhere. It drives our weather patterns, provides the energy for plant life, even influences our moods.
It's true. The sun is the engine that drives so many processes on Earth. Its energy warms our planet, powers the water cycle, and creates the winds that circulate air and influence weather. And let's not forget the role it plays in photosynthesis.
Oh, yeah.
The process by which plants convert sunlight into energy, which forms the basis of most food chains on Earth.
It's amazing how something so far away can have such a profound impact on our daily lives.
It really is.
But we also have to talk about the flip side, right? The sun can also pose some threats to our planet.
Right. Those solar energetic particles we mentioned earlier can be a real problem when the sun releases large bursts of these particles during solar flares or CMEs.
Right.
They can disrupt our satellites, communication systems, and even power grids.
I've heard about those solar storms. They can cause all sorts of havoc, right?
They certainly can. A particularly strong solar storm could knock out power for millions of people, disrupt GPS navigation, and even damage critical infrastructure. And as we become increasingly reliant on technology, the potential consequences of these solar storms become even more significant.
It sounds like understanding the sun and its behavior is not just about scientific curiosity, it's also about protecting our planet and our way of life.
Precisely. That's why missions like Parker are so crucial. The more we learn about the sun's behavior, the better we can predict and prepare for these potential threats.
So this is really cutting-edge science with real-world implications.
Yeah.
It makes you realize that space exploration isn't just about venturing out into the unknown, it's also about understanding and protecting our home planet.
Well said. And when you think about it, that's what makes the Parker Solar Probe mission so inspiring. It's a testament to human ingenuity, our thirst for knowledge, and our desire to understand our place in the universe.
It really is a remarkable achievement. And as Parker continues its journey, venturing closer to the sun with each pass, who knows what other groundbreaking discoveries await us. It feels like we're on the cusp of a new era of solar science, and I can't wait to see what the future holds.
It's truly an exciting time to be studying the sun. And who knows, perhaps Parker's discoveries will pave the way for even more ambitious missions in the future. Maybe one day we'll send a probe to actually land on the sun's surface.
Wow, that would be incredible. A true testament to the power of human ambition and the relentless pursuit of knowledge. But for now, we'll have to content ourselves with the amazing insights that Parker is sending back from its daring journey.
And those insights are truly reshaping our understanding of our star and its influence on our world.
Well, listeners, that brings us to the end of our deep dive into the Parker Solar Probe's historic, close approach to the sun. I hope you've enjoyed this journey of discovery as much as we have. Keep your eyes on the stars and stay curious, because the universe is full of wonders waiting to be explored.